I will start by saying good afternoon, good morning. I would say good morning to Diva, and thank you all of you for being here. I am Ana. With me is Gonçalo, my colleague from Siena, and let me start by introducing Siena briefly. We are a Portuguese NGO. We focus on marine conservation. We deal with issues such as fisheries, marine litter, marine protected areas, and others. And since the pandemic started, we started to host these webinars, which were a great surprise for us because we have had a lot of people joining us. We have had some incredibly interesting webinars, and this is going to be one of those for sure. I would like to let you know that this is being recorded because we usually share our webinars afterwards on our YouTube channel for everyone that could not be here or could be here and wants to see it again. I hope that's okay with you, Diva, and with all the participants. Let me tell you about the structure of this webinar. We will start with a presentation by Diva. I think Diva will share her screen, and then we can all see the presentation, and then afterwards we'll have a Q&A session. It's usually highly participated. We have usually questions from the participants, and I invite all the participants to leave the questions and the comments and suggestions you may have on the Q&A box on the bottom of your Zoom screen. It's quite easy to write these questions, and then afterwards we will select some of them, hopefully all of them, to start the conversation among the three of us. Unfortunately, people cannot speak, but they can write everything they want in the Q&A box, and we invite everyone to do so, even during the presentation. Why this webinar? Actually, deep seas, as Gonçalo was reminding me, deep sea has been one of the most recent subjects we have been dealing with, specifically deep sea mining, and that's why specifically we reached to you, Diva, because you are quite well-known scientist in these matters. And then I will introduce you. Introduce your work as well, and then you can add whatever you want, and then we'll start with your presentation. So let me tell you that Diva is a Caribbean deep sea biologist working at the nexus of science, policy, and communication. She participated in expeditions around the world and has an extensive science, communication, and outreach record. She's also a director and founder of SpeSeas. I think that's the way to pronounce it.
Close enough.
Which is an NGO dedicated to increasing marine science, education, and advocacy in Trinidad and Tobago, which is where Diva is from, and I think is where she's currently in. I'm not sure, but I think it is. Diva is also a Pew-Bertarelli Ocean Ambassador and 2020 National Geographic Emerging Explorer, a co-lead of the DOSI Minerals Working Group, and a scientific associate at the Natural History Museum of London. In this webinar, what we will do is to have an overview about the deep sea and the deep ocean biology and the pressures it's facing, more particularly deep sea mining, which is a big issue for us now here in Portugal. I think I said it all. I don't think I am forgetting anything. If I am, I'm sorry. And then we'll have the chance to continue this conversation afterwards. I think you can share your screen now. I enabled you to do so.
Great. Let me try. Gosh, it's always like, how do I do this again? Right. Okay, hold on. Bear with me.
We have been doing this
I know
for a year now. It's difficult still.
And still, it's not.
Yeah.
Yes.
Yeah.
Okay, let's try this. Share.
Yeah.
And let's try full screen. Where's that? Play.
Play. Yeah.
Is that working?
Yes, perfectly.
Okay.
Yeah, it's great. Thank you.
So firstly, I just want to say thank you to Ana and Gonçalo for reaching out and inviting me to speak today. And thank you to everybody who's joined us. I'm really excited to try to bring a little bit of the vast deep ocean to all of you and discuss this emerging issue of deep sea bed mining. I see I have a couple of deep sea bed mining colleagues on listening who are Portuguese, so go easy on me in the questions after, but great that you could join us. And yeah, deep sea bed mining, I would love to hear about it from a Portuguese perspective after. I know it's a rapidly emerging issue globally, but also especially in Portugal. And yeah, just, I mean, thank you again for that wonderful introduction. And if it's okay, I'm just gonna jump right in.
Yes, yes,
So my research tends to focus on trying to answer two questions. Firstly, what lives in the world's deep ocean? And how are we humans impacting that? And as Anna said already, a lot of what I work with right now is the issue of this emerging industry called deep seabed mining. So I think a great place to start is, you know, when we're talking about the deep sea, what are we talking about? Well, that's everything that's from about 200 meters depth all the way to the deepest point on the planet, which is just under 11,000 meters. And as you can see on this map, that's everything that's dark blue. So it is a vast area. Actually, the deep ocean provides about 96% of all the habitable space on the planet, or over 96%. And that makes it our largest ecosystem by far. And yet it's an ecosystem that we don't really hear about, right? In our day-to-day lives, we don't really interact with, and that's fascinating. So it's vast, it's remote, and it's very difficult to study. You need a lot of high-tech equipment to do so, remotely operated vehicles, submersibles, landers, and all of those things are very costly. And so the costs, the vastness, and the remoteness means that the deep ocean is pretty poorly explored. And when I use the word explored, what I tend to mean is, so if we think about from a mapping perspective, you know, we have better, higher resolution maps of the surface of Mars, Venus, and the moon than we do our own ocean floor. And the big difference there is, you know, the water sitting between us and the seafloor. But also just in terms of, if we take exploration one step further, maps are just the first step. And really, if we think about how much of the deep sea has been imaged with a camera or seen with human eyes, really we're talking about like far less than 1% of the deep ocean has ever been seen. And again, that's just a staggering fact, considering we're talking about our own planet. And so what that means for most of our planet is that, unfortunately, we really are struggling to answer the most basic question of what lives there, much less questions about how these animals reproduce, what they eat, what function they play in their ecosystem. And if you can't answer those questions, then really you struggle to answer questions about how we are impacting these animals, these ecosystems. And if we can't understand how we're impacting them, then we really struggle to come up with solutions. So for the first 100 years of deep sea science, and that, you know, that we're not much past that, the deep ocean was really assumed to be a lot like this. Looks pretty boring, pretty barren. You can see it's a sedimented plain where it doesn't look like there's a lot of life. You can see some what looks like tube worm type things, or worms in polychaetes and tubes, maybe a sponge, this sea urchin in the front of the picture. And this picture was taken at about just over 4,000 meters in the North Atlantic, I want to say, or actually North Pacific. But really, this is, you know, a typical picture, or what was thought to be a typical picture of the deep ocean up until the last few decades. And this really came about because the deep ocean is a really tough place to live. You know, there's no sunlight past about 400 meters. Temperatures are just above freezing, and they're really crushing pressures. And the other thing about the deep ocean that is very different to on land and in shallow waters is that there really is not a lot of food in the deep ocean. So because of that lack of sunlight, it means there are no plants. And so all of the food, the vast majority of food that makes it into the deep ocean actually comes from the sea surface. So plankton, animals, and so on, when they die, they'll drift the kilometers down into the deep sea, and in the form of marine snow, and there they can be eaten. So it means that the deep ocean is generally pretty food limited. But thanks to improvements in technology, we're really beginning to see that the deep ocean is actually not one big, dark, cold, boring place. Just like on land and in the shallow waters, there are a variety of habitats. So in the top left, we have seamounts, so mountains under the sea that have coral gardens living on them, and also quite big sharks. And then in the top right, we have lakes made of brine that is 3 to 8 times saltier than the surrounding seawater, and it sits on the seafloor because it's denser, forming this lake that actually can like ripple and has a sort of seashore surrounding it that's actually made of mussels and other animals. In the bottom left, we've got more seamounts, these mountains, but this one is a particularly unique one. It was only discovered in the last 5 years, and those little animals you can see sitting on it, those are octopus. That were thousands of them were discovered, all sitting, brooding their eggs on this seamount in their brooding position. They're kind of like upturned. And then also, not only are we finding that really, you know, there is this vast number of deep sea habitats, that also means that there is a vast number of deep sea species. So really, biodiversity is quite high in the deep ocean. And we think that about 2/3 of all the species that live in the deep ocean are still to be discovered, which is, of course, really exciting. And because of, again, these increases in technology, not only are we finding new species, new habitats, new behaviors, but we're also seeing species in a much newer way, a different way than we ever have. And so that bottom right video is a sea cucumber that was taken by Mbari. And they've actually shown that, you know, far more animals than we ever imagined in the deep ocean produce their own light by bioluminescence. And they are able to see this using some very cool technology, low light cameras. So really, again, we're just scratching the surface of what we know about the deep ocean globally. And it really is going to herald absolutely incredible discoveries in the coming decades. So something else that we've learned from the work that's been done so far is that actually most of the life in the deep ocean is quite slow. So for instance, because of that lack of food, you know, if you think about if you were starving, you wouldn't exactly enjoy doing a 100-meter sprint or even running a marathon, right? You would really limit your activity. And not that the animals in the deep ocean are starving, but just that they live in this food poor environment, and so their activity usually goes with that. And that means they move slowly, they grow slowly, they can get to very, very great ages. And they also, you know, not only can they get to great ages, but they take a long time to reproduce, and we don't necessarily understand a lot about their reproduction. And what that means is in the deep ocean, not only do we know a lot, but we're finding that in the few animals that we have studied, you know, Greenland sharks can take over 400 years, can live for over 400 years and take 150 years to become sexually mature, which is astounding. Worms that can live for over 1,000 years. We have gold corals and black corals that can live for over 4,000 years. And then even more amazingly, we have glass sponges that can live for well over 11,000 years. So I mean, think about that for a second. One animal, right, being that alive for the length of time that it took humanity to essentially sort of, you know, discover and use the wheel, right? Like this, think about how much has passed in human history over that time span. And to think about one animal potentially being there for all of it, it really is very, just blows my mind, every time I think about it. But what is essential about, what I want you to take away from this whole thing you're looking at here is that timescales in the deep ocean are completely different to what you and I are used to. Things are just generally much, much slower. And what that means is that life in the deep ocean often struggles to deal with change. Recovery is not fast, and impacts therefore can be much longer lasting. So keep that in mind as we go on. And again, this increase in technology and increase in research has really led to a much better understanding of how important the deep ocean is. It is our largest ecosystem by far. Oh, hold on, what is happening here? Bear with me. Oh my God. Hold on. How do I even get this off? Can you guys see that?
I have not. Yeah, we can.
Okay, hold on. Wait, let me just get out and I'll go back into it.
It's great, yeah.
There we go, fine.
Yeah.
My apologies.
Okay, it's okay.
So what we're finding is that the deep ocean is also very, very important, much more important than we ever realized before. And that's because our understanding of it is really growing. So we know that because it is this huge ecosystem, it plays a role in many global processes, and global processes that actually keep the planet habitable and allow us to be healthy and continue on with life. And so, for instance, provisioning services, I should say, not resources, include the deep ocean has links to our fisheries, global fisheries that so many people globally rely on for nutrition, but also for livelihoods. We're seeing an emerging use of deep ocean genetic properties in deep ocean animals for things like pharmaceuticals and biomaterials and so on. And then we also know that the deep ocean plays a key role in things like climate regulation or waste absorption. The deep sea actually is a huge sequesterer of carbon and absorbs a lot of heat. And without it, our temperatures globally would not be where it is. And we also know that the one which is often underestimated is that the deep sea has cultural value as well. Just the fact that so many of us are gathered here today to hear about the deep ocean, it inspires, it educates, and it's aesthetically astounding. And I think also a lot of us get, and potentially even more in the future, hopefully, get some kind of feeling of well-being from knowing that there are these resources that exist and these amazing habitats that exist in the deep ocean, and also that we are good stewards of them. And that's really something that we shouldn't, again, underestimate. But as with everything, of course, there's now a problem. We're using our deep ocean more and more, and we're not doing so in a very careful way. And that means that our deep sea is changing. So those areas that are far from our coastlines and seemingly quite remote are actually not out of our reach. So for centuries, we have used the deep ocean as a place where we can dispose of our trash or our unwanted items. For decades, we have used it for fishing. And now more and more, we are seeing new industries emerging. For example, deep seabed mining, potentially. And of course, like the rest of the planet, the deep ocean is also, on top of all of these extractive uses, the deep ocean is also being impacted by climate change already. So we need to think about, not just climate change, but how those impacts from climate change and industries potentially are behaving with each other, and are they potentially even being synergistic or compounding the problem. And this is probably only going to get worse as time goes on. More and more we are exploring our deep ocean, and unfortunately, as many of us know, that exploring often leads to exploitation, and exploitation doesn't necessarily always happen in the most responsible or careful way. So deep seabed mining. What is it? Well, what is it going after? Essentially, there are three main types of mineral deposits in the deep ocean that are being sought after. All of them are different in nature, but where they're found and also the communities that live on them, but also the mining process at all of them will be quite similar. So we have polymetallic nodules on the left, and those are cherry to potato sized accretions of metal that sit on the abyssal plain, so about 4 to 6 kilometers depth, a sedimented plain, and they look almost like cobbles on a street, sort of. Then we have polymetallic sulfides in the middle. Those are also known as hydrothermal vents, and those are essentially oases on the seafloor where super hot chemical rich fluid gushes out of the seafloor. It forms these chimneys over time, and the fluid that is gushing from the seafloor powers ecosystems in the process via chemosynthesis, which is using the chemicals in that fluid to power life rather than the sun in photosynthesis, what we're used to. And those tend to be found on mid-ocean ridges around the world between 1 and 4 kilometers depth. So those are active vents, and something to keep in mind is that inactive vents will also be targeted. So these hydrothermal vents, they go through sort of lifespans, and they can shut off that fluid gushing out of them, and then the life will change to more of a to just a different ecosystem. And so those will also be targeted, potentially the mining process. And then we have cobalt-rich crusts, so on the right, and those are found on seamounts between 1 and 2.5 kilometers depth. And as you can see, each of them has different metals that they're being targeted for. But again, the mining process, which we'll get into shortly, is quite similar between all three. But let's talk a little bit about, often these are thought of as resources. That's how a lot of the conversation tends to go around these three environments a lot because of this emerging industry. But actually, they're more than resources. They are, incredible ecosystems in their own right. So let's talk a little bit about the life that is found of them and also how this mining regulatory process will work potentially. So as I'm sure all of you are aware, the ocean tends to be divided up into two sorts of regulatory environments. So if you look at this map, the black areas of the ocean are within a country's borders, so within their national jurisdictions, and those will be governed by the country that they belong to. But then all of the blue you can see on the map here is international waters, and that means that it belongs to no one really, or to all of us, whichever way you want to look at it. So because that has been pretty overlooked from a regulatory perspective, international waters, there's now been an intergovernmental organization called the International Seabed Authority that is based in Jamaica that is responsible for managing and regulating all of the mineral activities in international waters. And what is amazing about these resources in international waters is they are referred to as the common heritage of mankind or humankind. And what that means is that they not only belong to me and to you, but also to everyone who's on this call, to everyone on the planet, and also to everyone who is yet to come. And so managing something like that is obviously going to be quite challenging because it means that benefits need to exist for all of those people. And so far, this International Seabed Authority has leased 30 areas of seafloor, might be 31 now, but that you can see here on this map. So the red in the Pacific are the nodules. There are some spots of green in the Atlantic and in the Indian Ocean. Those are for vents or sulfides. And then there's also a nodule claim in the Indian Ocean as well. And then off to the right, in the western side of the Pacific, you'll also see some crust claims contract areas as well. And so these 30 areas that you're looking at here, I mean, they may not seem that significant given how vast our oceans are, but if you think about each of those 30 claims could be as much as 75,000 square kilometers, or roughly the size of Sri Lanka, suddenly the picture begins to shift a little bit. And when you think that the resource is so much greater, this is the potential metal resource in the ocean that we know of, that really it begins to become much clearer that if deep seabed mining does take place on the scale that it is anticipated to, then, and not done so in a responsible way, whatever that might be, then potentially we're looking at something that could be deeply problematic and have quite a severe impact on our ocean. So yeah, lots to think about there. But if we were to zoom in on that red area in the Pacific, the nodule area, this is an area called the Clarion Clipperton zone. As you can see, Hawaii is up to the left and Mexico to the right. And so you can see that this is quite a vast area of the Pacific. It's about the size of the continental US. And this is where the most valuable and sought after nodules are. And as you can see, it's where the most activity is in international waters. So there have been, I think, 17 leases granted in this area, and those are the colored blocks that you can see on this map. And each of those colors denotes a country, so a state-based entity or a state-sponsored company, for instance. And then the gray striped boxes are areas that have been put aside. They're called areas of particular environmental interest. And the areas that have been put aside where no mining is allowed to take place. So this is, as you can see, this is again quite a vast area, and one of these could potentially be about the size of Sri Lanka. So I was part of a team a couple of years ago, which was able to work in the easternmost light blue contract area you can see on this map. It belonged to UK Seabed Resources Limited, which is the UK's sponsored entity, and it's actually a subsidiary company of Lockheed Martin. So I was part of a team of scientists that from around the world that were essentially contracted to study the life in this area, to understand really what lived there, how it functioned, and really to just get that baseline that does not exist for the majority of these up until recently did not exist for the majority of these contract areas, but for many of them still does not exist. And our results were absolutely astounding. This is a video that was actually taken in the western end of the CCZ, but it just gives you an idea of some of the life that lives there. You can see the nodules sort of dotted on the sea floor. There are anemones, there are sea stars, there are sea cucumbers. And those are just the big charismatic sort of megafauna. But also where most of the life is in this area is actually within the sediment. Tiny, small animals that live within the sediment, as well as microbes. And what we found during some of our studies was that actually the Clarion-Clipperton zone The Clarion-Clipperton zone is one of the most biodiverse places in the deep ocean, despite it not necessarily looking that way at face value. But also that it potentially could be one of the most biodiverse places really in our ocean or on the planet. And for every 1,000 species of animal that we came across in that UK area, we were just working in a 30 by 30 area during each cruise. And for each of those 30 by 30 areas, we were coming across roughly about 1,000 animals. And of those 1,000 animals, 900 of them were new to science, roughly. So we're talking about 90% of species that we're finding in these areas being new to science. And this is kind of an indication of the level of knowledge we have about this area. And what was pretty depressing to learn was that most of the large animals, which is what I tend to work on, actually were found to use the nodules themselves. So for instance, this anemone you're seeing here, it is attached to a nodule. And corals, anemones, sponges, they actually use those nodules as a substrate for them to attach to anchor to, like the sponge you're seeing here. And without those nodules, of course, the things that will be removed during the mining process, the ecosystem will change dramatically, and a huge portion of the biodiversity will be lost. But there's, of course, still a lot of work to do to understand this area more fully. We essentially just sort of scraped the surface. And these are hydrothermal vents here, the second environment. And these environments are just so amazing. I don't even know where to begin. So as we said, they gush this super hot chemical rich fluid, which you can see here that kind of looks like black smoke. And that black smoke is actually just, I think this particular vent that fluid was about 400 degrees Celsius, and it's just that black color because of all the metals in it. And you can see the chimney looks very metallic, and that's because that's where the metals are. But as you can also see, there's a lot of life, shrimp, mussels in this particular vent that we were working on in the Pacific. And what is amazing generally about hydrothermal vents is that they were only discovered in 1977. So we've known about them for, this is where my math's going to fail me, around 50 years. And, and despite them being quite tiny areas of the seafloor, they really do just have a huge amount of life associated with them. So if you took all of the active hydrothermal vents globally and added them up the area, it would only equal about 50 kilometers squared, so smaller than the island of Bermuda. And that's all of the hydrothermal vents that we know of globally. So globally, these are quite a small, rare resource, essentially, or rare ecosystems. And again, a lot of the life that we're finding there, most of the animals were new the first time they had been come across. around 80% of species live, apologies for the noise, that is a gardener, like not a gardener, but someone mowing the lawn next door. And we're finding that about 80% of species live only at hydrothermal vents, so high levels of endemicity. And a lot of the animals living there have really incredible adaptations. They can withstand, quite high temperatures for the deep ocean. They can withstand interesting quite high chemical concentrations. And they provide us with information about how life may have evolved on this planet and potentially have evolved on other planets. So really, these are pretty spectacular. And this specific vent that we're looking at here, just to tell you again that we're really just still in the discovery stage in the deep sea. This was the first time this vent was imaged. It is over 10 stories tall, and it was only imaged for the first time in 2016. So, again, less than 5 years later, we still know very little about this environment. I don't think many scientific teams have been back there since, but this is a huge structure that again, no one knew about until very, very recently. And then these are the cobalt-rich crusts on seamounts. This was taken in the Pacific as well, which is where the most valuable crusts are. And because of the structure of mountains in the sea, in the deep ocean, that structure means that currents sort of tend to upwell around them and then circulate. And that results in a lot of trapping of nutrients. And this plethora of life emerges, essentially, not just above the seamount in terms of fish, many commercial fish we target, but also just marine mammals, turtles, seabirds, etc., but also sometimes on the seamounts themselves. So this is one of the most astounding deep sea environments I've ever seen. This was found again in the Pacific, and it was nicknamed the Forest of Weir because these sponges and corals were just blow mind. And this was the first time this was ever seen, just about 3 or 4 years ago. And these corals and sponges, they tend to form, they're almost like rainforests of the sea. They create this 3-dimensional structure like trees, and they then allows lots of other life to live in them. And as you can see, the crust is that they are attached to the crust themselves. And again, as you heard already, some of these corals and sponges can live to extraordinary ages. And seamounts are probably at least the ones where deep seabed mining may occur. Those are probably the environment that we know the least about of the 3 resources and habitats being targeted. So, and I'll skim through the rest. Oh my gosh, how many times is this gardener gonna pass?
we can barely hear it.
Okay, great. It's quite loud here. So just to sort of wrap up, these places where mining may occur, we are still, again, sometimes the first time anyone ever sees them and studies them is as a result of these baseline surveys which are a precursor to the mining process. And so we still have huge scientific knowledge gaps that need to be closed before potentially moving forward. So yes, we are discovering new species, but actually it takes a long time to give them names and do their taxonomy, as I'm sure many others on the call will attest to. And we also know very little about their distributions. Yes, they occur here, but where else do they occur? Do they occur only here? We know very little about how they reproduce, which is a key puzzle piece in managing places and knowing how they will be, how resilient they will be to human impacts like deep seabed mining. We know very little about the water column. I mean, we're just talking about the seafloor here, but of course, most of the deep ocean is actually just that water, that 3-dimensional water above. And so we know very little about what lives there and how the connections exist between, for instance, the sea surface and the seafloor. We know very little about the environment, especially in the southern hemisphere, as has been seen in many other areas of science. There is that lack of information related to the global south. And that is where a lot of the mineral resources are being targeted as well. We know very little about, again, the connectivity, whether that is genetic connectivity or ecological connectivity. And those are key pieces to understanding how a system functions. We don't really understand much about how variable these environments are. That is definitely increasing, and all of these things are increasing, and we know more than we ever have, but we still have a long way to go, and especially around things like temporal variability. Because deep sea science is so expensive and we don't get to do it very often, or as often as many of us would like, it means that often we go to a place once and never go back for like a decade or more, or ever, if ever. And so really we are missing, you know, those sustained observations that that I think we wish we all had, and that will allow us to understand how these environments vary in terms of lunar cycles, or whether there are storm events in the deep ocean, or, you know, just generally how long things take to potentially change and recover. And then, of course, going back to the surfaces, we know that the deep sea plays a role in things like sequestering carbon and things like, you know, detoxifying the ocean and so on. But we really are struggling to understand how that actually occurs. Like, to what extent does that occur? And how potentially would it be impacted by various activities? And so the mining process is, while it has not happened yet, there's been no commercial mining. There have been a few tests that have occurred, but none of them have been on the scale or severity level of which commercial mining will occur on. But those tests have been very helpful for us deep sea scientists to understand patterns of recovery and so on, or at least give insights into patterns of recovery. And so we know that the mining process is going to be destructive. As you can see in this diagram, there'll be a machine or machines that move along the sea floor, and animals within the path of the machine will be destroyed during the mining process if they are unable to move, which most are unable to move or move quickly. And the seafloor itself will be removed or severely disturbed. Then the resource will be pumped up to a ship waiting above, where it will then be dewatered, and that wastewater, which may have methyl particulates or sediment in it, that will then be pumped back into the ocean. And deep sea mining companies haven't actually disclosed or necessarily aren't sure what depth that will potentially occur at in our ocean, but that depth is key to understanding potential impacts. And so during that mining process on the seafloor, as well as that pumping back of that water, that will create plumes of sediment, plumes of warmer water, plumes of water that is very chemically different from the water that was there before. And that will essentially extend the mining footprint because of the three-dimensional environment in the deep ocean and in the ocean generally. That will extend the footprint of mining potentially way beyond the actual footprint of the vehicle. And that's potentially where most of the impacts are going to come from, that plume. And of course, there's also going to be things like light pollution that, you know, many of these animals may never be exposed to, noise pollution that could be quite severe. But again, a lot of this is just, we need more information essentially to be able to more effectively constrain the impacts of deep sea bed mining. But we know there will, whatever way you look at it, whatever way it's done, there will be a loss of biodiversity. And if we don't know enough, that could potentially result in species extinctions and so on. So this is one of the areas where a deep sea bed mining test took place once upon a time in the Pacific. And what happened here was a trawl was dragged along the sea floor, and you can see that there. You can see the nodules sitting around. And again, because of that slow recovery we talked about at the beginning, this environment that you're looking at here, that, you know, a plow like this, you know, happening on land, if you think about that being done on a farm, for instance, those plow marks would probably disappear in a few months at most. But actually, this trawl mark that you're looking at here was done 26 years ago. And as you can see, it still looks pretty fresh, which is deeply concerning. And of course, not just are the trawl marks fresh, but the nodules themselves, which take not millennia, take millions of years to form. They tend to deposit on a grain of sand like a pearl almost does, over millions of years. And so even if the sediment goes back to normal over perhaps decades or centuries, or even millennia, the nodules themselves, and the same with the vents in the crust, that hard substrate that many of the animals rely on, will not deposit, inactive vents I should say, will not deposit for millions of years. And that means a huge component of these ocean ecosystems will be missing. And again, there are these huge gaps around the mining process. We are not sure what is permissible, at what society would consider to be permissible in terms of impacts in the deep ocean. And we're not sure really, even as scientists, and regulators, what we should consider to be that point at which, you know, harm is unacceptable, that serious harm definition. And we're not even sure what indicators of ecosystem health we should really be looking at. So, you know, what are those sort of tipping points? Like perhaps is it dissolved oxygen? Is it sediment concentration? Like we're not sure what should be those triggers for potentially mining should set those sort of ground rules or those constraints for mining to occur in. And that's because we just don't understand the way the life works down there and the way that these ecosystems function. We also really are struggling with things like the spatial extent of the impacts, the plume. How far will that go? And that's, of course, not just the plume we can see, but also the plume that is dissolved. A lot of these metals and so on may be in solution. And then that impact on ecosystem services. Ultimately, we are a pretty selfish species, and we need to know how things impact us. And that's one of the big questions that we're still not sure. Will deep sea bed mining have effects that potentially affect the services that, you know, potentially fisheries? Could there be metal uptake in fisheries, or could the ocean's ability to sequester carbon be altered? You know, these are questions that we just don't have answers for yet, but they're really important ones. What are the extinction risks for many of the animals? How long will recovery take place? I mean, we have an idea about that one, and it's that these ecosystems will not recover in human timescales. It'll be more on geological timescales, and that's something we need to say whether that's something we deem acceptable. And again, as I mentioned at the beginning, this cumulative impact question: how will the impacts of mining potentially like synergize with those of climate change? So, what I sort of hope that, you know, this is the last slide, but what I sort of hope that I've shared with you today, what you take home, is that the deep ocean is a fascinating place. It is not only home to incredible life and incredible ecosystems and important ecosystems, but also to resources that could potentially help us in the future. And, you know, the deep ocean has consistently written the way we think about life on this planet. And it is going to herald, as I said before, some of the most amazing discoveries in the coming decades. But, you know, we need to think carefully about how we treat the deep ocean and how we potentially move forward using it. For instance, you know, is it better to mine the depths of the ocean out of sight and out of mind, away from humankind, in order to preserve habitats that we interact with more regularly? Or should we be exploiting places that we don't understand? Could we be losing species and habitats and functions before we know, understand, and value them? And, you know, are we potentially trying to, let's play the video again. Are we potentially trying to almost avert one planetary crisis? The climate crisis is the main reason used for deep seabed mining. Are we potentially trying to avert one crisis by potentially creating what could be a crisis in another environment? You know, again, there are some really difficult questions to answer. And the fact remains that if we break the deep ocean, it's going to be really, really tough to fix it. So we just need to be sure about these actions and make really informed, scientifically informed decisions as we move forward, really, because that's, I mean, ultimately, as we've seen with everything in the last year, science really needs to be the basis of everything, and that's how we're going to potentially be able to manage things a little bit more effectively and responsibly. So yeah, that's it. Thank you for listening, and I'm very much looking forward to questions.
Thank you so much, Diva. This was great. We were discussing, me and Gonzalo, that this is a lot of new information for us, and it's great that you can give it to us in such a cool way and in such a light way, even though this is a pretty complex issue. And before we start with the questions, let me tell everyone, because we had a lot of people joining us after you started to talk, and everyone can leave their questions and comments on the Q&A box. We already have some, and we'll try to be quick. But I just wanted to make a general comment, because when you were talking about the species that you found out, it was almost 90% of the species were new when you were in that area. And one concept that was in my mind all this time, all this presentation, was precautionary principle. It's and
Exactly.
it's the place and the subject to apply it. I mean, not the only one, but it's absolutely clear that we should apply this principle. And most of our legislations, at least in Europe, have this principle in we have it. We usually deal with it, and it's quite difficult to understand how can we start thinking about deep sea bed mining when we know so little about it. It blows my mind, actually. That number, actually, it was a lot of information for me.
Yeah, I think a lot of people just think that, when, for instance, a new animal is found on land, it always makes news. It's a huge thing. And I think because of that, a lot of people, globally think that we know all of the life on the planet, right? But actually, there are still lots of animals being discovered, not just on land, but especially in the deep ocean, because this is the first time often when we go there for science, or when commercial entities go there, that is the first time they're ever being seen. And it's just, discovering species is just one part of it. It's like, how, that being able to have that whole ecosystem understanding is still quite a way away, I think, unfortunately.
Yes, yes. Great. So we'll start with a question from Luis Fazenda. I think you can read the question also if you open your Q&A box, Diva, but I will read it. And Luis is a colleague of ours, and he say, hi and thanks for this wonderful presentation. In the context of the climate emergency, and knowing that the oceans are the largest carbon sink on the planet, what is the state of the art in terms of the role the deep seas play in carbon regulation, and what is understood about how deep sea mining could impact the carbon cycle of the oceans? You talked about this a bit. Do you want to add anything?
Sure, I can touch on it a bit more. So we know, Louise is completely right. The ocean is the largest carbon sink on the planet, but we're still trying to understand exactly where most of that carbon is and how that carbon reaches the deep ocean, how long it is stored for, et cetera, et cetera. So there's a lot about the actual sort of specifics that we don't understand yet. But for instance, and I should also add that a lot of the stuff that we do think we know, or a lot of the stuff that is our state of the art, is from modeling approaches. And of course, a lot of people know that modeling relies on pretty robust data in order for modeling outputs to be as robust. And we are still in a data deficient environment. But the state of the art of what we know so far, a study came out, I'm sure everybody saw it, it was all over the news, in the last 2 weeks by Enrique Sala and others. And they looked at which places in the ocean were most important for carbon, were the most important carbon sinks versus the most important for biodiversity versus the most important for fisheries. And they then took all those three things and made maps that showed essentially where we should protect in order to protect those three oceanic functions. And this was the first time that was ever done. It's a groundbreaking study. I encourage everybody to go and look at that paper or just read the news stories about it. But what they actually found was that there's a lot of the areas closer to land, so on the continental slope that comes down from continents into the deep ocean, is a part of the deep ocean, but it's definitely in the upper reaches of the deep ocean. Those are incredibly important. And so they have actually advocated for a lot of areas within countries' borders being protected in their oceanic water, within their national jurisdictions. But also places like seamounts, were flagged as being absolutely essential to protect because of the key role they again play in plankton blooms and so on, and food and biodiversity, and also hydrothermal vents as well. We, in the last couple years, a few studies have emerged that showed that because of all the iron and metals coming out of the hydrothermal vents, you know, kilometers down, that eventually makes it to the sea surface, and there phytoplankton use it and then bloom. And so actually it's shown how connected the sea floor, deep sea floor, is to the sea surface. And of course, the plankton is the basis of the food chain for a lot of animals in deep sea, and it's all connected. So anyway, in a nutshell is, more and more science is emerging. We know it is incredibly important, and but there is still a lot more that we have to understand about the deep ocean. I think when we uncover more about the biodiversity, the more about the links that the deep ocean plays in fisheries, as well as the links it plays in climate change, we're potentially going to begin to see our deep sea in a very, very different way. And right now we're just working in a very data deficient environment, which unfortunately is problematic for management.
I just pasted here the link to Enrique Sala's new paper, so that everybody can check it out. Thank you. Gonçalo?
Indeed. Yeah, well, thank you very much, Diva. Indeed, we've been working on deep sea conservation for some time, but indeed it's such a groundbreaking area. Every time we have the privilege of listening to someone who was on the forefront of the research, we get our mind blown. That just happens every time. So thank you again.
I would love to know more about the state of the situation in Portugal. I know that
we can touch upon
it's been discussed quite a lot. Yeah, I would love to, when you have a chance. Whenever.
Perhaps take it a bit more to the end, but absolutely. And indeed, I was just answering to a comment thanking us for the webinars. Indeed, we take a lot of pleasure ourselves from having people like Diva doing these presentations for us. So thank you very much indeed. And I'll just read the next question. Comes from Raf Custers. Nice to see you, Raf. We haven't talked for a long time, but good to see that you're around. So the first question that Raf has is, Belgian company GSR is on its way to test a collector in the Clarion Clipperton zone with a team monitoring of the movements of the sediments. What can you tell about sediments and life? Raf Custers, Brussels. You touch upon this again, but please.
Okay, so lots of things to touch on here. I mean, so yes, the Belgian company GSR is heading out to test the Britannia 2, and that is a small scale test of one of the collectors that potentially could be used. And these types of tests that use technology that is potentially as close as to what may end up being used are really useful for scientists to be able to understand the impacts more clearly. And I know that GSR are working with, have an independent monitoring team of European scientists. I think also Portuguese scientists are involved. And that's under, I think it's JPI Oceans, joint program of, yeah, but definitely there will be a team of independent scientists who are monitoring that test to try and understand as much as possible about it. But in terms of the microbes, so the area they're going to is the Clarion Clipperton zone in the Pacific, where it's just started to rain really heavily, is the area in the Pacific where nodules are being sought after. That's where GSR's contract areas are. And the sediments in that area, there's a lot to know about them, a lot to know about the microbial stuff. This is totally not my area. I study the big things, but I'll just touch a little bit on one of the studies that emerged just towards the end of last year. And again, this is all so cutting edge that the science is literally coming out as we're speaking. But they went to the area where you saw I think it was the area where you saw that track that I put in my presentation. And what they went back there after time, lots of time, many decades. And what they found were that even, several decades after the test, microbial cell numbers were still more than 50% reduced from background levels. And they anticipate that potentially the microbial communities might take, at least decades, at least 50 years to return to undisturbed levels. And of course, in these ecosystems, the nodule ecosystems of the Pacific and potentially other nodule ecosystems, the microbes are really sort of the base of the ecosystem. They're like our plants on land. They are, a crucial part of that ecosystem, and everything else sort of stems from them. And that's not just food chains, but that's also ecosystem services. So it's really important that we do work to understand these microbial communities and find out stuff about them. I remember during our surveys in the Eastern CCZ, it was uncovered that the microbial communities living in the water column are totally distinct from those living on the nodules, and are totally distinct from those living in the sediment. And there's a lot we don't understand about how the microbial communities potentially actually play a role in the formation of the nodules themselves. So I know work is ongoing. There are a lot of great microbial scientists working out there. It's just, we just need the science, potentially we need the science faster than we can get it, given the pace of the mining industry, potentially.
I think you touched upon the next question we have here. Was it on purpose or no?
Oh, I don't know. No,
okay,
I don't even know what it is.
Yeah. So it's a question from Miguel Smith. I just didn't know if you had answered already or if you wanted to continue. So it's a question from Miguel Smith, and he says, thanks for the inspiring talk. As a microbial ecologist, that's why I tend to think about microbial life in every ecosystem. In your perspective, what are the main services provided by microbial communities in the deep sea bed, and what are the potential risks of deep sea mining to these activities? You said already that you're not an expert on this, but can you add anything else?
Yeah, sure. So I'll say to start that there is a brilliant paper that sums up the microbial services for all three of the environments that where deep sea bed mining may occur. It's by Beth Orcutt, O-R-C-U-T-T. And it came out in 2020 in, I think, Limnology and Oceanography. Yes. And it's a great review of all we know about microbial communities and functions in these three environments. But I'm just scanning her paper now, and we know that, it differs from between the ecosystems that where mining may occur, but we know that, for instance, there are things that are required for animal presence, especially at vent ecosystems. They provide biomass production, they generate nutrients, they play a role regulating the climate and other toxic gases like hydrogen sulfide. They contribute to carbon sequestration. They contain genetic resources that could be really useful during bioprospecting and for pharmaceutical industries and so on. And they are, of course, the basis of scientific research and so on. And that's just a very general statement, but I do encourage you to go and look at that paper, because it's just really succinctly sums up what we know about microbes in all of these environments.
Can you just repeat the name, because I missed it, the paper?
While we're talking, I'll Google it and put it into the chat.
Okay, great, thank you.
Yeah.
Thank you very much. I will take this opportunity to do just a little update, Diva, then before I go to Jean-Carlos' question, which connects, I think, well to this. So basically in Portugal, as you may have known, there were rumors of a contract with a now extinct company called National Minerals. Mm-hmm. Yeah, what we were able to understand is that if there ever was a contract, it is not valid anymore because of a legal decision that invalidates anything that was signed unilaterally, in that case by one of the regional governments. So
okay.
What we know at this stage is that there are no active contracts with the mining companies. We are on the lookout, but indeed we've been putting a lot of pressure on Portugal to be a voice for a moratorium, which we think, because of everything that you just repeated in this webinar, makes full sense. I think it really screams to me that humankind is not ready to do this activity in this place. We do not know enough. So basically, in a gist, that's it. But we're trying to get a bit of a stronger and clearer position from the Portuguese government, because there's been different voices from the government saying relatively different things. There's also a big push for online mining for lithium. And
Yep.
so, yeah, at this stage, we're not sure, but we're trying to steer them towards a really precautionary position. But let's say it like that. And also thinking that Portugal indeed can be a leader worldwide in pushing for a group of countries to go more precautionary on this and to defend a moratorium.
I may be mistaken, but didn't your Minister of the Sea, Ricardo Serrao Santos, didn't he say recently that something? Yeah, you can say, you probably know better than me, but
he's one of the voices for a long time now that has really advised caution. So we're really trying to support him on this. But as I said, from the government, you have relatively different positions or communications. You have no official statement by the Portuguese government on seabed mining, and that's what we're trying really to get out in the public. But indeed, Minister Santos has been a very active voice for deep ocean knowledge and conservation for many years. And so we would expect nothing less from him, let's say like that. But of course, politics, it's a complicated...
It's complicated.
Yeah, if I may add something, we are pushing for this, especially. I mean, not just because, but we want to take this opportunity because Portugal has the presidency of the European Council during this semester, and we think it could be a great opportunity for us to make this public statement saying that we do support, that the country does support the deep sea bed mining moratorium, and especially with all the documents and all the agreements that have been signed in this past, I would say, 2 years maybe, we think it only makes sense to align the public speech with the actions that are being done. So we are still trying to get one position, a good one for us. We hope so. But yeah,
we, at least from my view, I think what I would like to see is a bit of a domino effect, and I'm pretty sure if some countries really come out publicly pushing for a moratorium, I would say that a lot would follow. That's maybe it's me being optimistic, but I think if there's a political momentum building, then it will carry itself forward. But this was a bit. Of course, Diva, we're always. It will be a pleasure to talk more with you on this. But this was also already answering a bit to João Carlos. My view and Siena's view is that indeed we don't need it, and we can't do it right now for sure. But I would ask you, Diva, for your views on this. Is it really necessary?
$1 million question.
Explore this deep sea mining, and what's the benefit? What would be the benefit for us? Thank you, Jean, for your question.
So I think it's certainly if deep seabed mining were to begin in the next 2 to 5, even 10 years, I think we would be going into it quite blindly. And that is absolutely the opposite of the precautionary approach, as we heard from Anna earlier. And so I think, the moratorium really allows science to gather more of the answers to the questions that are still there. And it doesn't necessarily preclude mining from happening in the future. It just means that we will have more answers to make more informed decisions and go forward in a more responsible way, potentially. I think the technology isn't, there are still some pretty big gaps in apart from science, apart from all the environmental gaps, there are regulatory gaps from an international perspective. And there are also gaps around the financial side of things, like how will these benefits be shared amongst humankind? So there are some pretty big puzzle pieces that are still missing. And a moratorium, again, allows those puzzle pieces to be found and put into place potentially. But in that time, I think we saw probe land on Mars, right? Which was an astounding feat for humankind, and that we were able to watch it in near real time, and even do that and then watch it. And so I think, if we are at this really pivotal time for the planet, for the ocean, and I think in the next couple of years, technology can move a long way, and we're seeing a lot of the demand, or a lot of the supposed demand for these metals is potentially what the deep sea mining companies are saying is that it's for batteries, for renewable energy. And actually, we're seeing that a lot of the batteries are now, the technology is moving so that a lot of these metals are being removed from the batteries themselves. A lot of these metals are being removed from the batteries themselves. So technology is moving forward in ways that we didn't anticipate it potentially would. And I think we're also seeing a bigger push for more of a circular economy as well. People are waking up to a lot of the problems. And I think I was on the news last week, but some pretty big companies, I think as it was Anna who suggested, or Goncalo, I can't remember, but we were talking about that domino effect, and Volvo, BMW, Google, and Samsung all came out last week with WWF and said that they would not be sourcing their metals from deep seabed mining until it was deemed that this could potentially happen in a way that was not potentially harmful to the environment. And that's great, right? That's, I think, all a lot of scientists and conservationists and NGOs would like to see, is that we're, again, just making informed decisions, that if there is going to be damage, that society is well aware of that and then have accepted that that is potentially the way they would like to move forward. This is a societal decision that needs to be informed by science. So I hope in the next couple of months, weeks, months, years, we're going to see more companies signing on to these types of statements, and that can potentially send the signal that, hey, we do need more science and we do need a better understanding, and that rushing into these types of environments is just repeating what we've done on land so many times.
Yeah, I just pasted here the news about that you were mentioning, because it was a really unexpected, I would say, news for all of us working on this on these issues. I have another question from Raf, but I will do as I usually do, which is we already posed one question from Raf, and then if we have time in the end, we will ask this question from him again. I hope he doesn't mind. Then we have a question from George Ramos, and I was trying to understand a bit what George was trying to ask, because he mentions Greenland elections, and I'm honest, I had to Google.
Oh yes, I saw that. Yeah.
Yeah.
Oh, that's great that you're following this, Diva, because I was also Googling it.
Yeah, I didn't know, honestly. As far as I understood, there's elections happening in Greenland and mining inland, I think. It's it's being an issue. I would say. Yeah, George said that it's shaping local elections. And I think that it's interesting because we are starting to see that people are aware of these issues and do care about what happens and what are the impacts. So do you have anything to add on this? What do you think about this subject in particular?
Yes, so I actually read about this yesterday. So yes, in Greenland, they're having their elections, and they're sitting on potentially one of the largest sources of rare earth minerals in the world. And there are plans that are being supported by one political party to begin mining them, whereas the other political party, as far as I understand it, which is a political party of indigenous, with mostly indigenous representatives, is against it. And this is one of the most contentious issues being put forward in this election that is happening now. And I think, it hits home two sort of points, is that ultimately a lot of this is a political process, and it's the same thing with deep seabed mining. These discussions are happening amongst governments and national delegates in the international fora. And unfortunately, I mean, at least in this case in Greenland, the public has a say and is able to cast their vote accordingly. But that is not necessarily the case with deep seabed mining. These conversations have been happening amongst a small group of people so far, but the general public does not tend to know about this issue, and as such does not tend to engage with this issue, unfortunately. And also it's particularly poignant that, for instance, Indigenous voices have been missing. Many voices are missing from the negotiations at the International Seabed Authority, but one of the most poignant is that of Indigenous voices, which has so often happened again in history before. So, you know, I think these types of issues are gonna continue to emerge, but it does appear that the general public, which is great, is beginning to think more about the effect we are having on the planet, and beginning to act accordingly and vote accordingly when that is possible. But we need to see more representation in those discussions around deep seabed mining in the international space, definitely.
Yeah.
Thanks, Diva. Indeed, thank you, Josh, for bringing this issue, and of course, thank you, Diva, for your answer. And I think you really touched upon another key issue about seabed mining, which is being disregarded. So I'll go and read Catarina's question now. Catarina Magalhães, thank you, Catarina, for your presence and for your question. Catarina says, thanks, Diva, for sharing with us such a complete overview about deep sea ecosystems and their main threats in this excellent presentation. Eerie, Catarina, I echo your words. Then Catarina says, I would like to ask you if these mining activities already start in any part of the ocean, and if there are any global rules that are applied to all countries, or if each country has their own rules in terms of deep sea exploration. So again, something you touched upon in previous answers, but please feel free to add.
So thank you, Katerina, for your lovely comments. And just to add that, you know, this presentation is merely like a drop in the ocean of the deep ocean and the stories of the deep ocean. I do encourage you, if you have time, there's so many great resources on the deep ocean, whether it is videos from NOAA's Office of Ocean Exploration or Ocean Exploration Trust or Schmidt Ocean Institute. They just have the most incredible videos online. So please, if you have time, go and explore them. But in terms of your question about the regulatory processes. So if you think back to the presentation, there was that map with the black and the blue. So within national waters, which was the black, those are the country's waters themselves. Each country will be responsible for setting their own regulations about mining in their own waters. But no commercial mining has occurred anywhere globally yet in the deep ocean, really, for these metals. But there are movements for it to be done within national jurisdictions. So places like Norway, Japan, the Cook Islands, for a long time, Papua New Guinea, through Nautilus, the company that Goncalo mentioned, they were potentially going to see mining happen within their waters. But that entire activity went bankrupt and left Papua New Guinea's government massively in debt. But so none of it has happened yet within a country's waters, but many countries are in the process of setting up their own laws about how to govern that activity if and when it does occur. In international waters, the International Seabed Authority is responsible for those laws, those regulations, and they currently have regulations that allows the exploration related to these minerals, but they do not yet have laws that allow for exploitation, so mining. This is something that is actively being worked on. For instance, they are on their 5th or 6th iteration of these regulations. And there's still a lot more work that has to go into them. There's, been a lot of talk that they're going to be completed this year, but I think that's a pretty ambitious goal, if so. So all of the regulations are not in place for international waters yet, and that means that no one can go mining yet in the international waters. So but we are seeing tests happening, and those will all be governed by international regulations. But yeah, so it's just a rapidly moving space, and certainly something to keep an eye on for sure.
Thank you. We are heading to the end of this webinar. So if you have any burning questions, please just drop them here. I think we have two. two more questions, and then we can close. And then our next question is from Joaquin. I hope I'm saying this right, Joaquin Claudette. And he says, "Hi Diva, how do you see the MPA designation process in the future BBNJ COP interacting or not with ISA to ensure parts of the deep seabed is efficiently protected from direct impacts?" And he adds, "Great presentation, by the way."
So thanks, Joachim. I think you are the one who should be answering this question, not me. I know Joachim well, and he is far more proficient about the BBNJ process than I am. You know, I think this question highlights that there are still a lot of problems around ocean management in general, of our international waters. It's still especially siloed. So fisheries is managed by the FAO and our FMOs. Then we have a BBNJ process, which is these negotiations are undergoing right now at the United Nations. And that potentially is meant to take a much more holistic look of international waters and how we manage them. But then you also have things like the ISA that is responsible for minerals and the seafloor, and then UNFCCC COP, that's about climate change. So we still have things really quite separate when it comes to managing the deep ocean, and that just doesn't work, right? We need to be taking this much more holistic view, and we're just not there yet, unfortunately. So I think that, you know, it's interesting because the BBNJ process is not mentioned much at the International Seabed Authority. And I think that's almost because there's a direct conflict between the two almost. How can you manage? I don't see how the seafloor and the water column can be separate things and managed in separate ways, given the connectedness of the ocean. So, you know, again, it's really going to be something to watch as to how the BBNJ negotiations and that treaty end up interacting with the processes happening at the ISA. There are big question marks around it. But hopefully it remains to be seen whether there will be some sort of synergy between the two, or whether we just end up with this continuing, what's the right word? Like segregated ocean currently, which, as we know, the ocean is not segregated in any way and needs to be managed in a way that is not segregated. But I mean, sorry, and I'm just going to add one more thing because I'm just looking at this question. So part of the BBNJ negotiations, I realized I didn't actually answer the question. One of the big things is about going to be designated marine protected areas on the high seas. And that will be extremely exciting when it does happen. But again, because the ISA manages the seafloor and BBNJ does not have jurisdiction over the seafloor, how those MPAs may actually end up being implemented. For instance, they may say that we're going to protect this part of the ocean, but it does not include the seafloor, and then mining can occur there. So it's, yes, potentially shaping up to be a bit discombobulating, but certainly something that I think, you know, we need more eyes on, and we need more scientists to be vocal about the need for MPAs to encompass all of the ocean, from the sea surface to the sea floor, and ensure that they are fully protected, because we know that is what works best for marine protected areas.
Thank you very much, Diva, and thank you, Joaquin. It's a pleasure to have you in one of our webinars. Maybe
I highly recommend, please invite him to give one.
I was thinking that. Maybe
that's punishment, Joachim.
we have the pleasure of having Siena people that work with Joaquin closely, so we know his work quite well, but it's still really a true pleasure. And thank you, because you really brought an important discussion of this debate. I think breaking the silos is something that we hear quite often recently, and I think it's becoming more and more of a need. I'll read a quick question from Raf Kasters again, and then Anna will finish with another one. But the second question from Raf is, we look at Western companies getting ready for the SM. Have you got a general view of the companies crusading for the SM, mainly Western or other?
Okay, so I'm just trying to find it. Again, this is not my area of expertise, but there's been a report that came out last year by Greenpeace that has really shown that the main proponents pushing deep seabed mining forward in international waters are actually Western private companies. So it's a bit hard to explain, but basically each entity that has a license for deep seabed mining has to be sponsored by a state. But so for instance, the UK sponsors UK Seabed Resources Limited's license, but they are a subsidiary company of Lockheed Martin, which is an American company. Similarly, let's use Deep Green, which is probably one of the most infamous companies related to deep seabed mining. They have contracts with Tonga, Kiribati, and Nauru, all Pacific small island developing states, but yet they are a company registered in Canada, I think it is. So there's a report that has come out recently by Greenpeace that has really shown that there is a significant imbalance almost in who is participating in this potentially new industry and who is essentially calling or really pushing it forward. But there has been a huge shift in the industry has rapidly accelerated with the emergence of these private companies playing a role. So that would be Deep Green, GSR, Global Sea Minerals, Sea Mineral Resources, and UK Seabed Resources Limited. Those three private entities have really accelerated the conversation. And whereas previously it was state-sponsored entities or state-owned entities. And I guess then there was less drive to satisfy investors and so on and reap profits. So there's been this shift in the conversation, but this report that came out by Greenpeace is I will try to look for it while we're chatting, but has really shown the imbalance that exists so far in this industry, in this rapidly emerging industry. Really, yes.
I think that Luis just pasted it here. I think
Great,
it's the same
thank you.
about. I'm going to paste it again because Luis only put it to us, and then I'm going to paste it to everyone.
Okay, I found the exact report, so I'm putting that in now.
Okay.
There was a lot of press around the report when it came out as well.
Okay, thank you. And it also shows the need, as you were saying before, to include the indigenous people, right? It's connected. So we have 3 minutes left, and we are going to end on time, I think. Thank you so much, Diva, once again. And the last question is from Rita São Marcos, and she says, thank you, Diva, for such an inspiring talk. I second Rita also. With so many potential and still so unknown environmental impacts for the planet and humanity, and being so expensive and costly to conduct scientific studies in the deep sea, I have some difficulty in imagining the cost-benefit analysis that have been supporting the economic interest in these mineral resources. What economic benefits are expected from the industry in specific? How many millions or billions are we talking about? I'm not sure if you can answer this.
My God. Yeah,
is it that sufficiently viable and lucrative enough to justify such an investment? Is this a new gold rush? Wow, this could be another webinar, no?
Yeah. Definitely, and I can highly recommend some folks who can give a webinar all about the legal side of seabed mining as well as the financial side of seabed mining, because it is really like a whole minefield in itself. I'm going to post a paper that in the chat that I was a co-author on last year. This paper stemmed from the high-level panel blue papers that for the Sustainable Ocean that were done last year. And in it, it's just a really good summary of a lot of the issues surrounding seabed mining and about, it's called The Challenges to the Sustainability of Deep Seabed Mining, and it touches on not just the environmental aspects, but also the legal and the financial aspects. But, you know, as I mentioned before, the financial aspects are still a big question mark because the ISA has not yet worked out how that payment regime would work, like what types of percentages would be for humankind versus the deep sea mining contractor versus what the ISA gets, and so on. So there's a lot of there's still a lot unknown there, but there are certainly concerns raised about who would be getting what essentially. So I do encourage everyone to have a look through that paper when they can. And again, I can recommend some really brilliant experts to discuss that side of deep seabed mining, if that's helpful.
Cool. We are going to make sure that we share all the links that have been put here in the chat with everyone. And that's it. I don't know, Diva, if you have any closing words for us. It was great for us. It was great, and the feedback we are getting, it's also very, very positive. So I don't know if you want to add anything else.
Just to say thank you again for having me, and I do encourage everyone just to learn more about the deep ocean if they can. Talk to others more about the deep ocean and these types of issues, because I think that there's a lot is being capitalized on people's lack of knowledge and the lack of scientific knowledge and so on. And so the more we can get these types of conversations into the mainstream, I think the better off we might all be. But thank you again for joining me.
Thank you so much. And I would add, from our side, from the NGO-ish side, I would advertise people to be aware of what's happening with the deep sea, and also to be involved in the public policies that in the discussion, and to ask questions to the civil servants, and to hold them accountable. And I think that's the way to go. And to us, it's always a pleasure to have people, researchers, and sometimes not researchers, with such extensive and profound knowledge about this issue that we are starting to work on. So I thank you once again, Diva, for your availability. I hope that everybody enjoyed this. We are going to post this on YouTube, and everybody's going to get the link. I will send it also to you, Diva. And that's it. I hope I'm not forgetting anything. And we will please just keep an eye on Siena's social media, because we are going to have other webinars, because we are very happy with the outcome of this, and I think we are going to keep on doing them. That's it. I think I don't have anything else to add. Thank you once again, Diva. It was a pleasure, and I hope you have a nice day. It's just starting.
Yeah, thank you so much, you guys. It was lovely to meet you, and thank you everyone for listening.
Thanks.
Bye, guys.
Thanks everyone. Bye. Till soon.